this is going to be 3.1, and this is going to be 1 and 2 step inequalities. All right, so 1 and 2 step inequalities are going to be a lot like 1 and 2 step equations. Okay, so the first thing we just need to understand is what is an inequality and how is it different from an equation, because there is a slight difference from an equation. So, an inequality is a statement that two expressions are not equal, usually using greater than, less than, greater than or equal to, or less than or equal to signs. How many of you, whenever you were in elementary school, your teacher taught you about the alligator that eats the bigger number? Right? They might not have called it an alligator, but usually whenever you're in elementary school, they teach you that the sign eats the bigger number, which is very good to know. What I find is a lot of kids in the 9th grade still can't tell me what this sign is. Okay? What is this one? Greater than. Okay, so you need to know if it's pointing to if it's the alligator's eating the number to the left, it is greater than. What about if I put the line underneath it? Greater than or equal to. Okay, if I have this one, that one's my less than. If I have the line underneath it, less than, or equal to. So I need you to be able to read this off to me out loud by saying x is greater than 5, right? Not the alligator's eating the x, right? That's not very mathematically correct. It's still a good thing to help you remember stuff, but you need to be able to know what these are, so make sure you know. If you are looking at your hands like a greater than and a less than sign, to do the less than, you have to use your left hand. It's supposed to start with L. So that might help you if you get a little mixed up with them sometimes. But we need to know what those are. And yesterday, whenever you were doing the IXL, when we graph these for a greater than sign or a less than sign, what type of circle? We used an open circle. So I'm going to put it out here. Those are open circles whenever we graph them, because the point's not included. It's like a hole there. All right? But if it's or equal to, closed circles. So whenever we graph these, we're going to do that. So what we're going to be looking at today, does everybody have to stand? We're good to go? Okay. What we're going to be looking at today is examples that look like this. Negative 3x is less than 15. So there is, in general, you're going to solve these like we've been solving equations. There's not a lot of difference, except for one thing. Did you guys do inequalities like this last year? You might not have. I can't remember if it's an 8th grade curriculum or not. I know equations are, but I don't know about this. Does anybody know the difference? Has anybody seen this before and know the difference between inequalities and equal signs? You may not have seen it, so that's fine if you haven't. I can't remember if it's in the curriculum or not. So there's one big difference that you have to watch out for. So let's put us a star over here and make us a note here. If you multiply or divide by a negative number, you must flip the inequality sign. You might imagine this is one of the biggest mistakes students make because it's easy to forget to do it. So let me show you why we have to do that. Okay? So, for a second, put your pencils down. Don't write what I'm going to do because it's going to be wrong. And we're going to see why we've got to do it, right? So don't write this down because this is going to be wrong. I'm going to lock this in place so I can. Alright, so if I was going to solve this, it's a one-step equation. I got the -3 next to x. What do I have to do to get rid of the -3? Divide both sides by -3. So, on this side I would have x, and on this side I would have -5. Alright, so I did not flip that inequality sign. I just left everything the same, just like we've been doing problems, right? So, if I think of my answers, if I graph my answers on the number line, because we'll be doing that, so here's -5, -4, -3, -2, -6, -7. So if I was going to graph my answer here, would I use an open circle or closed? Open. Do I shade to the left or to the right? To the left. All right, because our yesterday we were seeing our arrow looks like it's pointing this way, which as long as your x is first, you can just shade that direction. So if I did this, that means my answers would be numbers like -6, -7, -8, -10, -100, right? Well, let's plug some of those back in to see if it makes this true. If I plug in -6, -3 times -6 is less than 15. What is -3 times -6? Not -18. Positive 18, is that less than 15? No. So, we did not flip the sign. So, real quick, if you're dressed up today, go on out there and get your picture made. Alright, wait a second. It is wrong because 18 is not less than 15. 18 is bigger than 15, right? And if we put like if we put any number down, like if I pick negative 10, that's down here, right? That's on this side. Negative 3 times negative 10 is positive 30. That's not less than 15 either, right? So all those numbers are wrong. That's actually the ones that are wrong. So we're going to have to... No, we are going... I'll show you how to do it correctly here in a second. So to fix this, all we got to do is flip that inequality sign. So when I divided right here, I should have made that a greater than sign. So I went from less than to greater than, which means I'd shade this way instead of over there. And see, these numbers will work. Like if I have negative 4, negative 3 times negative 4 is less than 15. That's positive 12 less than 15. That's true. 12 is less than 15. So that's what we're going to do here. Once they all get their pictures made. The stuff I've done right here, no. Make sure you got this if you multiply or divide. Yeah. Yeah, I'm going to erase it here in a second. We'll do it right. But we'll wait for the photo shoot. Okay. Okay, so let's talk just a little bit more about why this is wrong. Like if I picked another number that was down here, like negative 10, right? That's a number that would be shaded here, even though it goes off the number line. Negative 3 times negative 10 is positive 30. Is positive 30 less than 15? It is not. What the answers actually are to this are the numbers over here. Like if I did negative 3 times negative 4, right? This number right here. That would give me positive 12. Is positive 12 less than 15? Yes. Or if I did negative 3 times negative 2, that's over here also. That'd give me 6 less than 15. Is that true? Yeah. So what's the problem here is I really should have shaded in this direction. But I didn't because I went with the same sign that I had here before. So now you can pick up your pencil. I'm going to erase this stuff and let's do it correctly. So what we need to do, we still do the same thing that I was doing before. We still divide by negative 3. So you can write this down now. I'm going to do it correctly. This still cancels. We still get x over here. We still get negative 5 over here. But because I divided by a negative, I have to flip this sign right here. So we see right here it was less than. I've got to make it greater than. So I'm going to highlight that there. The less than sign turned into a greater than sign. You only do this if you're dividing or multiplying by a negative. And most of the time it's going to be dividing. There's not too many problems where we have to multiply by a negative, but it does happen occasionally. So if you divide by a negative, you have to make sure to flip the sign. So if we graphed our answers here, negative 5, negative 4, oh, that's negative 6. These are negative numbers. Negative 4. We'd have open circle, but this time we would shade to the right. And those numbers are the ones that make this inequality true. So that's the difference. That's what we've got to watch out for. Okay? So let's do another example. Let's do a two-step this time. Oh, no, not 10, not 10. Hold on, let's do, let's do 14. Okay, so we just solve it like a regular equation. Peyton, tell me what I do first. I mean, you're right about having to mess with the 4. We got to move it, but how do we move it? We do not subtract. We add. Very good. So we got 6x is greater than or equal to 18. And then, Peyton, what would we do?
Then you do 6x divided by 14. They're not divided by. Are we doing it on the line?
We are trying to get this x right here by itself. Which means we got to get rid of the 6. How do we get rid of that 6? Good. On both sides. Good. So that just leaves me with x over here. I got 18 divided by 6, which is going to give me, give me 3. And do I have to flip the sign here? No, because I didn't divide by a negative, right? I just divided by a regular number. So my answer is going to be 3 for these. You are going to graph all of your answers. Well, I think it's going to be on Delta Math, but I think it has you graph your answers as well. I'm pretty sure. I know it does at least on some of them. So when we graph our answers, should I use an open circle or a closed circle here? Closed. Should I shade to the left or to the right? Right. Okay, questions? So your answer is two-part. This is your answer, but this graph is also part of your answer. I think on Delta Math it's going to have you give both, or at least on some of the problems I know it's going to have you give both, but some of them it might just ask for the inequality, some of them it might just ask for the graph. Whenever I give it to you multiple choice, sometimes I might give you the answer as inequality. Sometimes I might give it to you as a graph instead, so you need to know how to do both. All right, let's do another one. Alright, so some of these are the fractions. We're giving you guys trouble on the test, but they're not really fractions. So, Vince, what would I do to solve this one? Good? Good. So that's just going to give me x over 3 is less than 15. What would I do next, Vince? Good. And that's just going to cancel my 3 over here. And I also have to do that other side. So I got x less than 45. Good. Okay. No sign flipping on this one. We didn't even have a negative to really deal with. So if I graph that, 45, 44, 46. Passion, should I use an open circle or a closed circle? Open. And should I shade to the left or to the right? Okay? It's going to be left on this one because as long as our x is first, when we look at this, it kind of looks like an arrow pointing that direction, so that's the direction we're going to shade. As long as your x is first.
How did you get it 3 and 3?
So right here what I had was x over 3 is less than 15. So that's x divided by 3. So to get rid of something that's divided by 3, you're going to multiply by 3 on both sides. And what that does is it's really like multiplying by 3 over 1. You got a 3 in top and 3 in bottom. It cancels, so it's just gone. You don't multiply anything by 3. It's just gone. Over here, you multiply by 3 and get 45. Yes, multiply by that denominator. Good. All right, questions? All right, let's do example 4. And I'm giving you mostly 2-step equations because they're a little tougher than the 1-step. You'll have some 1-step also. But mostly 2 is what I'm focusing on here. Let's do this. 8 is less than or equal to negative 6 minus x. All right, Easton, tell me what you would do here. We got to get that x by itself.
Get rid of the 6.
Good, and how do I do that? Okay, I'm going to add that 6. Beautiful. So 8 plus 6 is going to give me 14. And make sure right here that you keep that negative. This is a negative x, which I can also think of like it is a negative 1x, right? Passion, put the phone away. Okay, so, Easton, what's the next thing that I would do?
Divide
Good. And so what am I dividing by?
the negative 1.
Good. Just the negative 1, no x with it, just the negative 1. So I would cancel these out. I would get negative 14. I would get x over here. But what did I just do? Alarms should be going off. Fireworks are going off in the background. I divided by a negative. So I've got to flip the inequality sign. It was less than. I've got to make it greater than. So we got negative 14. Negative 13 would be up here. Negative 15 would be down here. Doing that. All right, so, let's see, Alyssa, do I need to use an open circle or a closed circle for this one? Closed circle. Which direction do I shade? Do I shade to the right? To the left on this one. I purposefully gave you this one to try to trick you. Because we can, so right here, my arrow does look like it goes this way. Is my x first? No, the x has to be first for us to use that trick. So we need to go the opposite direction, which means we need to shade here. Here's what I usually do. I never, ever, ever leave my answer like this right here. I always rewrite it 14 greater than or equal to x. I always rewrite it. I put the x on the left-hand side and the negative 14 on the right-hand side, which if I do that, you can see right here, the alligator was eating the number 14. Actually, it's that way for you guys, right? The alligator was eating that negative 14. So when I rewrite it, the alligator still wants to eat the negative 14. I've got to switch it back. There. So if you, this is the difference between equations, because if you switch the equal side of an equation, it doesn't matter, right? X equals 3 is the same as 3 equals x. I can just flip them, it doesn't matter. But if I've got x is less than or equal to negative 14, I've got to flip that sign when I rewrite it. Okay? So if you flip it to put your x first, then you can look at the sign and see that it points to the left. But only if you flip it to put your x first. Okay? So we would have x is less than or equal to negative 14. Our graph would be here. So be really careful with those. Let's do a couple more, and I'm going to let you guys work on your assignment. So we got example 5. Let's do negative 3 is greater than 4 plus x over 2. All right, so Caroline, what would we do first on this problem? Very good. So we're going to multiply by 2 over here, which is cancels, which is what we want to happen, which means we also got to multiply by 2 over here. So I got 2 times negative 3 gives me negative 6. Over here I've just got 4 plus x. Do I need to flip the sign? Okay? No. I did not multiply by a negative. The 2 is what I was multiplying by, even though this is a negative 3 here, right? But that's not what I was multiplying by. I was multiplying by 2. It's positive. Don't have to flip the sign. What would we do after that, Caroline? Okay, we're going to subtract this 4 here, and if we do it on this side, we also have to do it over here. What's that going to give us, Caroline? Perfect. Do I need to flip my sign there? I'm just subtracting. Adding or subtracting, never flip your sign. It's only for multiplying and dividing. Okay? Alright, so let's see, Katie, open circle or closed circle? Shade to the left or shade to the right? The left. I was trying to trick her. I couldn't do it because it's opposite. I would have rewrote this. X is less than negative 10. The alligator is eating the negative 10, so if you rewrite it, the alligator's got to still eat the negative 10. So it needs to point to the left there. Okay, questions? Let's see, is there anything else? Let's see. Example 6. Let's do 8 minus 2x over, this is really a 3-step problem, but I'm going to give it to you anyway. Negative 3 is less than or equal to number 6. Alright, I want you guys to try this one on your own. Alright. Here's my work. It's fast, wasn't it? Okay? Alright, now, some of you could have possibly gotten it right by being lucky. So, let's make sure you're not lucky. Right here, when you multiply by negative 3, you have to flip your sign. But, right here, when you divide by negative 2, you end up flipping it back. Yes, every time you multiply or divide by a negative, you have to flip it. So you flip it the first time when you multiply by the negative 3, and then you got to flip it again when you divide by the negative 2. Some of you might have just got lucky because you didn't flip your sign at all, and it just happened to be right at the end. That usually is not going to work out for you, so be careful with that. 36 would have been right there. Yeah. All right, questions? Okay, you will need your computers because your assignment is on Delta Math today. So let me show you what we're doing today. Let's see. Foundation. Where's it at? It's not there. Did I put it in the wrong class? Maybe I put it in the wrong class. I might have to fix it for you.